Okay, so now, this is our goal for this unit. To identify and classify your polynomial. So we're going to talk about your polynomial, your leading coefficient test, which you guys know most of this. You know when you're negative, we have like negative x squared, your parabola opens down. When we have negative x cubed, it works differently than your positive x cubed does. That's your end behaviors. We're going to look at those. So this is our goal in doing this. And we're going to still build on everything that you know. Domains, increasing, decreasings. We're also going to find a couple of new things in here. Now, remember when I said we always look at your highest exponent and we can tell how many roots it has? We're gonna hit this a little bit more. If your highest exponent, say your highest exponent is an even number, then your graph is either going to go up or go down. If it looks like this with nothing else here, it's going to touch the x-axis, the x-axis right here, if it doesn't have any other thing to worry about. When we do this and we find your roots, we shift it around a little bit. These are where your shifts come in. When we complete your square, we find your vertex point, we go by your transformations. Your parent graph for this is just a basic graph. And you know this by, if it's even, it's going to open up. If it's odd, it's going to open down, right? I mean, if it's negative, it's going to open down. We have this. So this tells us what happens to our graph as well, what we expect it to look like. And when we saw x to the fourth, remember sometimes we got a w, sometimes we did get what looked like a parabola. So depending on how it is, how it comes out, it still opens up or opens down. The both ends go the same way. Your odd one, this is your cubing. This is when this guy is odd. Your highest exponent is odd. Notice your end behaviors. I know you like this one better because your domain is all real numbers, your range is all real numbers, and you don't have to pinpoint anything. Notice one arm goes down, the other one goes up. If we took the negative of this, it's causing it to go the other way, this way. It causes us to go the opposite way, but one still goes up, one still goes down. Okay? Now, we have a leading coefficient test that we do for this. And I gave you this in your notes. So, if it is odd, and let's say that this is y is equal to, I don't know, x cubed plus something or other, blah, 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 blah. If this is odd, this one here, yet your a is greater than 0, meaning this a is positive, your graph falls down to the left, up on the right. Okay, down to the left, up on the right. If it's reversed, if it's still odd, but it's a negative, then it goes the opposite way. Up on the left, down on the right. Okay? If it's even, and this looks like an x to the fourth one, plus something or other, that's even. If a is positive, both will go up. If a is negative, both will go down. Okay? And that part you pretty much know, right? Okay, and we're going to see more of these. Remember, a lot of these you're going to do without your calculator at first. Now, we're going to have a polynomial here. And we're going to find all real zeros. Where are my real zeros located? Your x-axis. Good. So if it's at my x-axis, what is the value of y? 0. So let's algebraically find this graph. We're going to plug your 0 in here. No different than what we did before. No different than what we did. We're just complicating this a little bit more. Let's analyze this first. What's the highest exponent?
4.
4. So this is an even number. Where do I expect, and let's look at your leading coefficient. What's your leading coefficient? Leading coefficient. Leading 1. But whatever has the highest exponent, find that coefficient. Your leading coefficient is 1. It's positive. So where is my n's going to go? My coefficient is 1, positive. My exponent is even. And my n's going to go this way, this way, this way, this way. Look like a railroad track. Aaron says this way, touchdown. I got a little touchdown post here. My n's are going up. Isn't this even? Think of like your quadratic, just your x squared. What does your x squared do? It goes up. If I put a negative, where does it go? Down. If it's an odd one, it goes opposites. So I know from my n behavior that I expect this one to open up. How many zeros do I expect to find? 4. Good. I expect to find 4 roots, 4 zeros to this guy. So let's factor this. What do they share in common? X squared. Okay, so what's left? X squared minus x minus 20. Okay, is there anything else that we can factor? Yeah, your trinomial. So what does this factor into? X what? X plus, x minus. Find factors of 20 that the difference gives me 1. 5 and 4. Which one gets a negative, Kyle? 5. Whatever one is in the middle, that's where your highest has to go. Now, is this factored completely? So now, let's set them all to 0. When we take the square root, this is your plus and minus situation, but it's at 0. When we take the square root of 0, this one is called a double root. This will bounce off the x-axis. It won't go through it. It will cause this to bounce off at the 0. Okay? So x is equal to negative 4, and x is equal to 5. Let's lay these guys out. We have a 0 that it's bouncing off of. We have a negative 4, and we have a 5. And both of our arms have to go up. So, at which points, where's my n behavior exists? At which one of these zeros? My n behavior says it has to go up, right? At negative 4 and 5. So doesn't this have to go up like this? Right? Very crude sketch. But doesn't it have to go up? Now, this has to bounce off this axis. Where do you think this came from? We made a W. It went like this. Wouldn't that be my graph? Right? So, let's try this and see if that's what it looks like. Let's go to your calculator and let's try this. Let's put this in your calculator. And try and see if it looks like that W. Guys, do this with me. Grab a calculator. Make sure you're doing this. Go to a Zoom 6 because you probably did your applications on this. Is that what I expected it to look like? How come I can't see the bottom? What do I have to do? Fix my windows. What should I change? My Y max would be up here. Minimum. Where should I go on my y minimum? Negative 50? Okay, let's take Aaron's word and say negative 50. Up, little lower, right? So go a little lower. Let's go to negative 100. All we want to do is see this thing turn. Is it turning? Does it turn evenly? So now we know from this guy that our sketch, what our sketch is exactly going to look like. So our sketch of this was a crude interpretation. It's going like this. We were pretty darn close, weren't we? Pretty darn close. Is this an even function? Is it symmetric over the y-axis? No, it's not symmetric over your y-axis. We thought it might look like a W, but we knew what our behaviors were doing. We knew we were bouncing off your y-axis, so we looked for all your real zeros. From this, can we find everything else? Can we find your domain, your range? Can we do a minimum? Is this an absolute minimum or a relative minimum? This would be your absolute minimum. How about this guy? Is this an absolute minimum? This one here. Relative minimum. Good. How about this one at B? Absolute maximum? Up here. Relative maximum. Remember doing these? Yeah.
You have to take the minimum of both of them?
Well, yeah, because they're not at the same point. This one is absolutely the lowest one you can go. This is what's going to help you define your range. We're not going to do that right now. I just want you to hit your zeros today. But tomorrow, we're going to incorporate all of this back together. Tomorrow, we're going to incorporate this back together. Now, all today I want you to do is just to find your zeros right now. And we're going to sketch in a second. All right, so now let's try another one. You ready?
What about the double root thing?
The double root. Where's your double root? Right here. So your double root counts twice. 2, 3, 4. Did we have 4 roots all together?
So the answer says, what doesn't pass is 4.
Yeah, it bounces off your x-axis, not through. Yeah, doesn't pass through. It touches your x-axis, it kind of bounces off. It can go either way. It can go from up here, or it can come from down here, but it won't pass through it. Okay? Questions? All right, so we found out what your highest exponent was, what your leading coefficient was, positive, so our arms were going up. We knew that. We knew we had to have 4 of these. This guy gave us a double root, so 1, 2, 3, 4 roots we have. And when we graphed it, we could see there's our W, and it was not symmetric. And what tells you it's not symmetric is right here. You've got a negative 4 and a positive 5. If they were a negative 4 and a positive 4, you could have symmetry. You could, but not in this one. Okay, let's try another one. It's kind of just building on what we already know. Now, let's sketch and describe this guy. This guy says, I have an odd exponent. I'm odd. What's my leading coefficient? Positive or negative? Positive. So, anybody remember where this should go? Like that. Down and up. Like this. Down and up. If you remember it that way, down and up. The opposite way is this way. That's the negative side. So kind of like the, what was that years ago with, oh, I can't even remember it. Okay. I'll think of it. John Travolta. Did that. Yeah, Saturday Night Fever. Did this all the time. Oh, where your graphs are going. Up like this, down like this. All right, so let's find your zeros. Let's find your zeros. Where do I find my zeros again? On where? On the x-axis. How many zeros should I have? 3. So let's set this equal to 0. What can I factor out? X squared, and what's left? x minus 3 over 2. Okay? Now, set these equal to 0. So, here's my double root. I take the square root. X is 0. I'm going to count twice. And x is 3 halves. So I have 1 here and 1 at the 3 halves. Now, let's see if we can figure this out. Where again does my end behavior come from, Jada?
Wait, what?
Where's my end behavior? Where does it go down and up?
You go to the positive first?
Okay, go here.
Yeah.
This is going up.
You go
Okay.
down.
And this one's going down. So where do you think this went to make me a nice smooth curve? I dipped here. Maybe we'll have it crossing over here. Do you think it dipped like this? Ignore this one.
I think it was lower.
Yeah, it probably dipped. Now remember, if it has 3 roots, 3 minus 1, it has 2 curves. 1, 2. 2 curves. Now, let's graph this and see if this is what we expected to happen. Let's put this in your calc and get a good feel for this. But you guys already pretty much described it to me. So let's see if this is what we ended up with. Alright, let's graph this. God help, we could do a zoom 6. Ah, I'm not really seeing this come down. Let's see what's going on here. X cubed, let me do a zoom 6 on this and see if that helps see it better, a little bit better. Ah, see it come down very little? You might want to lower your window just to see what's happening here. You might want to bring your window down here. Watch. This is a nice way to do it. X min, go from -5 to +5. Y min, go from -5 to +5. This will bring your window down, like, bring it in a little closer. See it? We knew that it turned, and we were right about our graph. So we have a graph that looks exactly, God bless you, exactly like that. It's coming up, it's turning slightly, and going back up. Everybody okay with that graph? We found your zeros, and we said it actually has 3. The 0 right here is your double root. 2, 3. And did it turn twice? 3 minus 1? 1 turn, 2 turns. Right? You know a lot from these graphs, right? Without even looking at your calculator. Your end behavior now tells you where this is going. Now, what I'm going to add into this is a little bit of something that you haven't seen yet. It's called concavity. Here's my graph. I drew it a little wider just so we could see it. We have concavity. Concavity has the word cave. What does a cave usually look like?
Big hole.
A big hole, but it's usually on the ground. Doesn't it look like this? Concave. Concavity. We say when the cave turns like this, it turns down. This is concave down. Here's your cave. This is concave down. It's turning downwards. This is concave up. My cave flipped up. It's turning upwards. So my graph is actually doing this. It's coming up here, increasing, increasing, stopping, decreasing, decreasing, stopping, increasing, increasing. To that, we're going to add your concavity. At this point, doesn't it make a down cave? And at this point, doesn't this make an up cave? So we've got an interval where it's going down. We've got an interval where it's going up. But we have a little problem. Somewhere along this line, we started to go down and then we changed our mind and went up. Do you see this one had shared both, where they both have a U? This right here is called an inflection point. It's called an inflection point because this is where you changed your mind. You were concaving down, and at this point in time you said, whoops, concave up. So, when we're looking for our concave down interval, we look for intervals. we're going to take this point, which is your 0, 0, and we're going to find your minimum point over here. We're going to take your minimum, and all we're going to do is average those 2 points. We're just going to average the x, because that's going to be halfway between this. When you take calculus, you actually use limits, derivatives to find those points. But for us, we're going to be real basic. We're just going to average those points together. So when we go to your graph, we're going to find this here. We're going to find our minimum. Guys, stick with me for a little bit more. We're going to find your minimum. Oh, by the way, is this called an absolute minimum or a relative minimum? Relative. So let's find your minimum here. So now we're going to go to the right. Okay? And we're going to find your minimum. Your minimum point, that's really the same as 1. 1, negative 0.5. Stay with me, guys. So here's my minimum at 1, negative 0.5. Remember, we don't care about the y values right now. Your minimum point here was at your 0, 0, at your maximum. Then your minimum point here is at your 1, negative 0.5. I just made the graph larger so we could see it. To find this x value, I take the average, 0 plus 1, and I divide it by 2. So this point has a minimum x value of 1/2. The y's, I can't always do that way. So what I do for the y's is I go here and I say, okay, if I give you a value, second trace value of 1/2, 0.5, tell me what your y is. Your y is negative 2.5. There's my inflection point. So your y value is negative 0.25. This is my inflection point. Everybody see what we did? We took the x's, took the average. We took the y's from the graph. Sometimes it works from an average, sometimes it doesn't. So watch. This is where we find our concave. Concave down comes from negative infinity until it hits that x point. Then you changed your mind and you concaved up. Guys, I have to hand you your homework yet. From 1/2 to infinity. Okay, what you're going to do is do these. You're going to do these for homework. I still have like 2 minutes. Sorry.
That was the whole packet.
Has graphs with a lot of space, yes. Okay, so do this for homework. Make sure you find these. The first part is just the whole first page is matching. You can put it in your calculator and just match a graph. The whole first page is matching.
How was that? Well, why didn't you get that sign? Well, not me. If I wasn't here, I was going
Nick, come in once you're ready.
Oh, yeah.
Good morning. On today's B-Day honor schedule to the main office, Joseph Harris. To Mr. Hill in guidance, Christian Bennett and Darius Perez. To Ms. Hurtado in guidance, Italo Cariari Russo. To Mr. Katz, Joe Silcox, Joshua Toffey, Dan Wallace, and Melissa Tagol. To Mrs. Krause in guidance, Samantha Alvarez, Christian Corona, Janisa Daniels, and Emily Hernandez. To Mr. Woody's office, Tiamani Roston and Noel Williams. To room 107 in transition, see Mrs. Lopez, Shaquille Dixon. Will the following students please see Mrs. Jones in the Guidance Career Center at this time? Jordan Matthew, Deshaun Mata, William McCartney, Andrea McCaskill, Shane McDonough, Ryan McGuire, Theo McKeon, Sean McNair, Carlos Mera, and Nicholas Burkhead. Again, those students, please see Ms. Jones in the Guidance Career Center at this time. Reminder to faculty and staff, if you have not yet done so, please make sure you go to Mr. Woody's office as soon as possible to pick up your parking tag. Out-of-date parking tags will not be recognized by the City of Newburgh Police Department. Reminder to students that Dominican College will be holding an instant admissions event here tomorrow, Wednesday, November 20th, from 10 to 1 p.m. in the West Side Lecture Room. Also, on Thursday, St. John's University will be conducting an instant admissions event in the West Side Lecture Room. If either of these colleges interest you, please stop by your guidance counselor's office for further details.
Doing that crack, sir. Well, not me. I like Google. Google was all over.
This thing. My microphone. Oh, am I still on? I never stopped. Crap.